Welcome back to Ox Tools. I'm Tom. Well, the word on the street is you guys are pretty desperate for some meatloaf, so I got you covered. Got a big batch of meatloaf here. It's actually a lot of stuff. It'll probably break into 2 episodes or two videos. So instead of me yapping, let's go look at some really cool stuff and pick up where we left off. Here's a setup you'll probably be interested in. So here's the problem, is I had a piece of DOM tubing, and for those that don't know, DOM means drawn over mandrel. So it's precision mechanical tubing. It has a good OD and ID, or pretty good for tubing. What I need to get out of here is pretty much almost as long as this piece of tubing is, and I needed to bore it. And the problem is when you stick it in the chuck and you squeeze on it, with a thin wall like this, it kind of crunches the tube down. So if you bore that with it crunched down, then you can get lobes on the inside, which I don't want for this particular thing. So I'm like, and this is the only piece of tubing that I have that's this size. It was that or bored out of solid, and I'm like, yeah, I don't want to do that. So what I did here was I kind of mixed it up a little bit, and I just welded on the back side of the tube. I welded a rectangular piece of steel, and I used silicon bronze here, which is kind of a low temperature, fairly non-distorting material, right? And these are just small welds. And then that's what I'm really gripping it by. You know, I got a really good grip on it there. And then what that allowed me to do was to very accurately indicate this, since I only needed to take a few thousandths out of the inside of the tube. So I was able to indicate it and get it straight with the world very accurately, and then so I indicated the outside, and then I reached on the inside just to check it, and then I can reach pretty far in there with an extended indicator to check the ID too. Let's pull this out of here and get a better look at it in case I want to put it back in. I'm just gonna loosen number 1 and number 2. Helps me remember. Okay, so you can see I had a pretty good bite on it there, right? But there's the welds. And then what I'll do is I'll just go cut those with a hacksaw or a cutting disc or something like that. Then I can just face off a little bit that I need to face off of this. And you can see that, I don't know if you can see down in there, there's one spot way at the end that didn't quite clean up. Like I said, I was only taking out a few thousandths out of this tube, and I'm going to show you what this is. This is just a test piece, a little prototype piece for something I'm working on, and we'll go take a look at that in a minute. All right, this first one, this is a cheapo digital magnetic level, and this particular one came from Harbor Freight, and in general, I'm not a super big fan of Harbor Freight, but you gotta give them credit. You can go buy something fairly cheap and kind of try it out, and if it's a one-time job, it's a great deal. This thing, Harbor Freight's not the cheapest game in town for these, but I really wanted one kind of right away. I could have ordered one off eBay or something and got a little cheaper, but I'm just going to turn it on real quick. What's cool about these, and it's going to show an error because I'm not holding it level. What's really cool about these is you can set a level reference that's not necessarily level. And what that means is if you have something that's out of level, but you want to put something at a particular angle to that thing, you can do that. Now, what I'm going to show you is how I actually had an idea for using this in the lathe to do some indexing that I needed to do for a little job. So it's probably better if we just pop over there and I'll show you the thing that I made and then how I did it on the lathe. So let's go scope that out. All right, so this is the thing I was making here, okay? And we're going to talk about this more in a minute. It's an ID lap that I was lapping the bore of something with that I wanted to be very precise. Now you see it's got grooves and radial grooves and then linear grooves here. And I was putting the linear grooves in, and I wanted them, you know, being the machinist that I am, you know, it was kind of needed to be indexed kind of accurately, at least visually, right? I mean, it doesn't make a hill of beans, okay? You know, whether these are spaced evenly or not, they're just slurry grooves. But, you know, it needs to be, they need to be indexed. So anyway, so here's the deal. So what you can do is, well, actually, it's pretty easy here. What we'll do is we'll just set it, we're looking at this here. I'm just going to set it at 0, I think. I think you get the idea. Okay, there's 0, close to 0. And what I did was I just indexed every 15 degrees, right? Which is pretty easy to do. And this reads to 1/10 of a degree. Okay. What am I doing? I'm looking at the little numbers, not the big numbers. There's 15, 14. Anyway, I think you get the idea. So now if you put it in a low gear, or I step on the foot brake or whatever, you know, kind of lock it down, but it didn't really matter for this. And then as you go around, this thing's kind of, well, let me do it here. It's kind of smart enough that it flips the display over, which is kind of neat. And then this has magnets in the base so that you can actually stick it onto different things like chuck jaws. Now, I lapped the bottom of this a little bit because it was a little humpy bumpy and it wasn't sitting very well. It wasn't consistent, so now it's better. But anyway, that's a reasonable way that you could cut fairly accurate angular indexing in the lathe. Now in this case I was using the lathe as a shaper, and I had a tool, and I was just kind of using the carriage to cut along this to make this lap. But let's go check this out on the surface plate, because I have a little angle block over there, and it's actually seems to read pretty good. So let's see that. All right, so what we got here, and this is kind of this is like super overkill. What we got here, this is a Starrett Crow Blocks 15-degree angle angular gauge block. Now you can see this one's a little bit beat up. This was an eBay purchase for, I don't know, 10 or 15 bucks, something like that. But it's still pretty damn good. So wipe that off. Now I have a set of angle gauge blocks, but they're not Crow blocks. And you know, 15 degree, it's not some weird angle, you know, it's kind of a useful angle. So anyway, I bought it. So what we're going to do is we're going to use this guy here, and I hope I'm looking in the viewfinder. Yeah, I think you can see that. Okay. So what we're going to do is we're going to let that settle for a sec. All right. So it's reading 0.4 degrees right now. And what I'm going to do is I'm going to hit the calibrate button. See, that's one complaint is the thing. Oh, there's a piece of crud under there. Watch out, Mr. Wizard. Okay, let's do that again. Reset. All right, so I'm going to hit the calibrate button. Let's see if it zeroes out. There it goes. Okay, so it's zeroed out. Now, unfortunately, Crow Blocks is not, there's 15 degrees, okay? So what I did, so just to refresh, what I did was this plate's not level, right? So what I did is I created a 0 reference and then compared something to it that happens to be 15 degrees, just to kind of, now, you know, how consistent is it? I haven't done any. It's back to 0. Okay. So I'd say this is kind of a useful thing around the shop. So check it out. They have them online. There's many different versions of it. Just make sure you get one that you can reset a reference. This one has, you know, % grade and something else. And then I think the other important thing to get is make sure you get some magnets in the bottom. So, okay. So now I know you guys are wondering what that lap was for, so let's take a look at the lap and we'll talk about the lap. All right, so here's the, this is the lap we showed just a minute ago here, And so this is aluminum, and what I was lapping was this little guy right here, and I was lapping the idea of this, okay? And this is a hard bronze bushing that's pressed into a steel sleeve. And we'll see what this is for a little later on, because this is a whole project here, or this is a prototype for a project. So, but let's talk about the lap for a second, because there's some, I don't know, maybe interesting stuff here. But you can create laps pretty easily, and this is this turned aluminum, and then drilled and split so that it has some springiness to it, and that it can expand in a over a short range in a fairly linear fashion. So, but expanding it from the inside, you know, ideally you want to expand it the kind of the full length of the lap, okay? So you can put a tapered screw in one end and do that, and that works. But the longer you get, the more kind of weird effects that you get. So what I did was I was like, gee, I don't want to build a whole gigantic thing, right? So I just want to, you know, it's always about the project, right? I want to make this tool so I can do this project and then forget about the tool, right? But then the tool becomes the potentially the more interesting thing. And what this is here, and a lot of guys already know what this is. This is a you know, when you crush your exhaust pipe because you're going over speed bumps or something like that, this actually fits inside your tailpipe, and you can push on these or tighten these up or whatever. Now I've modified this a little bit too, and it takes the dents out of your tailpipe, okay? But it does everything that we want it to do, right? So as we tighten up, it kind of expands around the OD, okay? But it's expanding, you know, along its length, not just on one end. And see, it has these little tapered, let's just take a look at it here. So you can see how it's put together here. All right, now, before, one end of this was threaded, and the idea was there was a bolt that went through it, and it was kind of a standalone thing like this, and you tighten the bolt up, and then it goes, and it does that, and it does this expansion, right? And these could be O-rings and or whatever, right? So you can actually make stuff like this pretty easily, but these are also pretty cheap. You can go down to the auto parts store and pick them up, and they have a few different sizes that would cover, you know, stuff like this. What you probably don't want is you don't want this to be super, super thick, right? And have a hard time expanding it and whatnot. And I put some drive pins in there, as you can see there, okay? So anyway, that's the part that I wanted to show you, was if you want to create a lap expander, that's, and there's some of the abrasive stuff. You can create one fairly easily, okay? The other way is you can do it solid and then use a pipe tap in the end, and there's some other ways to do it too. I think Robin Renzetti shows a couple of his laps that are kind of like that, so, okay? Anyway, that's what I wanted to show you on that, and like I said, we'll get to this in a little bit, and talking about what this whole project is here. This next one, I need a volunteer out there in internet land, and what we have here is these are a couple of laps that I made, and what these laps are for is they're for lapping the faces of micrometers, okay? So the idea is that you charge one side of these here like so, and then you can, I'm not doing a very good job here demoing it, and then you can actually lap the faces of worn micrometer anvils. So what happens is, as you're using these and you're going on and off, you know, your hand is tilting, so what tends to happen is the edges get rolled off, right? Now, the reason I need a volunteer is because I checked all my 0 to 1 micrometers or short range micrometers. They don't need lapping. They're in pretty good shape. It's probably from lack of use, but anyway, so I'm looking for a volunteer that's got a 0 to 1 mic or a 0 to 25 millimeter mic that has clearly worn anvils, okay? And so the idea is you would contact me, and I would you would mail it off to me, and then I would lap your micrometer anvils, and I'll just send it back to you, and that's it. That's the deal. So your micrometer will show up on a video, and the nice person that loans me a micrometer to lap, obviously will get some acknowledgement. So, which is kind of cool, right? So what we do then to check it is this is actually an optical parallel here, right? So this one's kind of interesting. It kind of flew under the radar on eBay. I saw it, and somebody called it a prism or something. I don't know what, but what it is it's an optical parallel, okay? And it's 512 in this direction, and then it's 525 in that direction. And that's what I saw in the picture, and I realized what it was, is it's for checking micrometer anvils, all right? So the idea is that you, let's make sure this thing's reasonably clean. You clamp the micrometer to it. Now we won't be able to see it here in this light. Oh, I can actually see it on that side. But when you look through the optical parallel, you can see fringes on the micrometer anvil, and you can look on both sides. And the reason it's different thicknesses is so in case they happen to be parallel in this situation, but this gives you a half rotation or whatever it is. What was it, 12 and 25? So it gives you a half rotation of the micrometer so that you can compare it at 90 degrees, right? Anyway, that's kind of the general idea of how that works. And like I said, it was a screaming deal. I think it was less than $20. So anyway, so bottom line is I need a micrometer. This is a lap that I made here, and what this is this is a piece of cast iron that I've ground and lapped very parallel. By my checking, it's better than 20 millionths parallelism between the two faces. And the way this works is, and I've marked it here, we've got side B and side A, right, is you only charge one side. And then it kind of behaves the same way as you charge one side with diamond, and then you clamp it, and then basically you lap the anvil, and then you clean it all off, and then you reverse it and lap the other side, okay? So this is just a different style. This is another way that you can make expanding laps here. This is just an adjustable parallel that I've surface ground and then lapped so that you can expand it into a gap and then use that as a lap. And these are cast iron, by the way. So now this side's probably no good because it's got a slot in it, or maybe it's okay because that helps with breaking, hydrodynamic wedges and things like that are in the slurry as you're lapping. But we're going to see more of this when I lap the edge finders that I got back from Robin Renzetti from Heat Treat. So anyway, I need a volunteer. Just contact me, and more than one's probably okay because I probably need the practice. So anyway, just contact me via email, and we'll set it up. Okay, so I mentioned this Heat Treat that I got back from Robin Renzetti. He was nice enough. He had a kind of a big load of A2 tool steel going out for heat treat, and I sent some stuff to him, and he got a heat treated in his batch. And these are some of the pieces, and I might have showed these before because they have this kind of weird red, purplish oxide coating on them. But anyway, after you work them, obviously they come back. This was one of the pieces that I sent, but this is what I wanted to show here. Was this, and this is something that's really easy to make. It's kind of a handy depth measuring tool here. Okay, so if you have an indicator, even a short travel one, you can create a real handy little depth gauge by just making a base that fits the shank of the indicator, and then is long enough that this thing can hide up in there, and then you can get a meaningful measurement out of it. Okay. Now the way this one works here is turn it on here. So it reads negative, and we set it on a, now you can set it on a surface plate, but you gotta be a little bit careful because this rounded tip here, it can find little divots in the surface plate and give you kind of an erroneous zero. So what you do is you just set it on a good surface like this, and okay, that's pretty reasonable here. I don't know what, I can't quite see it. We can re-zero it here. Oh, there it goes. Okay. So, and then now it reads as it extends. Okay. So what that's handy for is sometimes on the surface grinder when you're doing steps and things like that, it'd be nice not to take it off of the magnet, and you can go over there and kind of probe it. But this would be a good example here. Is you can measure this distance here, right? Okay. And then what I did was I kind of lopped the base off so that I could get up closer to an edge, and then this one's lapped on the bottom. So after I got it back from heat treat, I got the oxide layer off, and then I lapped the bottom so that it's nice and flat. So yeah, you can measure steps like that, okay, real easily, and just read it right off of the indicator. And that's a neat little project if you want to do a little. I mean, literally, you can make it out of this plain steel. It's not like it's going to wear that fast. And if you reestablish your zero frequently, then it will be fine. So anyway, this is probably the next one we're going to lap. The gentleman that will remain unnamed that sent me the Johansson comparator that this goes with was asking about it, and so this is back from heat treat, so we're going to lap this very, very flat, and we'll do this one the same too. So we have a flat anvil, and then we have a grooved anvil, and the grooved anvil is so that dust has a place to go. It shears the dust off as you slide something around on there. But we'll get into that in another video. And then ultimately we'll lap these. These are Scherr edge finders for picking up edges, okay, different styles. This is a Moore style here, and then this is a Pratt & Whitney style. And then the idea is that you put them up against an edge, and then you indicate in that little opening, and that little opening is exactly centered over that corner. So that's kind of the idea there. And they make commercial ones that will do two corners, or corners at the same time as opposed to an edge. So it won't stay up there. So and these are they're just slightly different widths. I didn't have a drawing for this one, so I had to kind of glean the dimensions, and scale it off of pictures off of the internet. But that's a copy of a Pratt & Whitney type. And then what's interesting here is we're going to be lapping two parallel surfaces there, which is actually kind of an excellent lapping exercise. So anyway, that's what I wanted to show you, was that thing, and then these are coming up sometime in the future. After I shot that last segment, I realized that it's been a while since I've shown this, and people might not quite understand what I was talking about with this this comparator anvil. So what this is it's a fancy indicator stand, and a gentleman that will remain unnamed sent it to me from overseas, and it was missing the anvil, and it was missing the indicator, but it's just a beautiful stand. This is made in Sweden, and so I made an anvil and I picked up an indicator, and the idea is this anvil slides in here, and these little screws lock it in place, and then you can trade sides if you want a smooth side, and slide that in and lock it in, and then you got a smooth side. So an indicator goes in here, and then you can raise and lower it down here. So it's just a kind of a studly, heavy-duty indicator stand. So you can do some very fine comparative measurements with it, and it's just a nice looking stand. It's got nice knobs, it's got some nice design details. And anyway, they don't give them away, I can tell you that. So, and they don't give these away either. So I made one. This next one's pretty interesting, actually. So this is something that
Robin Renzetti and myself have been experimenting with. And I have to say that it was kind of on the, there was a comment on one of my videos, and I can't remember which video it was, but a guy, we were talking about lapping in that particular video, and a guy mentioned that he does lapping on top of just regular aluminum foil, right? And I kind of didn't think about it for a little while, and then I started thinking about it, and it actually has some interesting advantages and lots of possibilities if it works. Well, guess what? It works. So let me just get to the point. It works. So I'm going to show you kind of how to do it, and that you can experiment with yourself. So what you need is you need some aluminum foil, and you need a surface plate. Just go to Scherr's or Grizzly and buy yourself a small, granite surface plate. Okay, and that acts as your flat surface. And because of excellent manufacturing, metal foils are actually extremely uniform in thickness, okay? And aluminum in particular has some desirable qualities as a lap, okay? But let's forget about the theory for a while, because I can see when I start talking theory about this stuff, you guys kind of drop off, okay? So let's just get to the meat here, and I'll go through it. So what I have here is I have a piece of tool steel. It's not hardened. And this is just a milled finish. I just milled this a minute ago and just dusted off that surface so that it's relatively flat. In fact, you can see the little lines, and and I can feel some little Humpty Bumpties in there just with my finger. Okay, so what that means is there's bumps in there that are probably equivalent to 1 or 2/10, something like that. Okay, so first step is, otherwise it'll take forever, is we're just going to go ahead and I'm going to use some of my stick down, and this is this blue ice, I think is what it's called, blue ice? Yeah, Norton, I guess it's not blue ice, it's something else. So I thought it was blue ice, huh? Okay, anyway, it doesn't matter. It's got a little adhesive on the back, and it just keeps you from one, getting dust underneath, which is detrimental to your surface plate, and it keeps it from moving around. Now, for all the people that are freaking out, this is my surface plate that I do sandpaper and weird stuff on. All my other ones are measuring only, okay? So all we're gonna do is we're just gonna flatten this off. And I'll say it again, I am not a fan of the figure 8. It really just doesn't work that well. All right, enough said. You have to experiment yourself. If you insist on doing it, then okay, you're on your own. Okay, so a little bit more. So I'm doing circles now, and I'm rotating the part a little bit just to get away from the dust, and then you can blow most of the dust off. Okay, actually we're looking pretty good. And I might pop up to the 600 just so we can do the lapping pretty quick. Now this is real time, I'm not speeding anything up, and that's part of what I want to do here, is kind of do this real time so you guys can see that you can produce a quality surface pretty quickly. Okay, so I'm going to call that good on the 400. So now I'm going to change this. I'm going to put 600. I'll bring it back for real time, and then we'll go through the whole thing. All right, so this is 600. I put a piece of 600 down. That's our 400 finish. So let's just go through. Give it. All right, so it's pretty close. You can kind of feel it. There's a lot of tactile feedback in lapping here. I still get some scratches in there. On the 400. Let me just do some nice high pressure linear strokes. All right, so yeah, I'm gonna go for it, okay? So 600 grit, let's get rid of that, all right? And now what we're gonna do, let me set that aside, clean the plate a little bit. This is just, you know, Joe McGee Reynolds wrap here, okay? Nothing, you know, nothing fancy. So what's neat about this is it's cheap, okay? So just gonna smooth it out a little bit, okay? And then what I'm gonna do is I'm gonna tape it down, at least a little bit anyway. Actually, let's go up. Actually, yeah, this piece is actually just kind of a teeny bit too big here. All right, you know what? We're still gonna go for it. So I'm just gonna tape two edges down. I'm just gonna go crude here, right? So you just never know what you're gonna learn until you start playing with something. So Robin's actually making use of this technique to lap his granite surface plate, but he and I talk on the phone pretty regularly, and you know, it's something that we've both been talking about and exploring. Okay, so I'm not too spazzed about wrinkles and stuff, and so this is just a piece of linear shaft. Oop, see, nice job there, Mr. Wizard. Okay, there's a speck of something there that I don't like. All right, well, it doesn't matter. We're not going to use that area, okay? I'm just going to fold that over. So first off, this is protecting the surface plate, right? But when I push down on it, I have my flat surfaces right there, okay? It's underneath. And so it's not actually wearing. Now what we're going to do is we're going to use some, it's this diamond lapping compound, and McMaster sells this. You can buy it off the internet. I mean, there's just lots and lots of, let's see, what else we get, 20? Let's just go with the 12. This is 12 micron, okay? And I'm gonna put a little bit down, and when I say a little bit, I mean a little bit. That's probably it right there, okay? And then I'm gonna add a drop of Kingsford lighter fluid. Okay, and literally just a drop. Okay, now I'm gonna go right on top of the diamond, and I'm gonna spread it out a little bit. Now what's happening here, let me tell you what's happening, is this is soft compared to this, so the diamond is actually sticking. It's starting to stick in the aluminum foil. Okay, and so now what we're doing is we're creating a diamond lap, and you see that dark stuff? That means we're doing something. Okay, so let me, I'm going to bring you in closer. So I'm going to stop, bring you in closer. I want this to be real time so you guys kind of get a sense of just how quick this is. So I'm going to put a little pressure on it. See all that dark, happy stuff? That's swarf. Now, I really don't want the foil to rip. Okay, so let's just give it a wipe, see what we got. I'm just wiping it on a cloth here. Oops. All right, so it's starting to come in there nicely. All right, let's keep going here. And then if I don't like this spot anymore, I can move to a new spot. Oop, okay, I think I just nicked the foil, so I'm going to stop there. I heard a little dink of the foil, and what I'm going to do is I'm just going to come over here, put a little down, little dab will do ya. Oop, and a teeny bit of lighter fluid, and I'll spread that around. Let's spread it in a little bit bigger area this time. I got more room to work. So I'm just concentrating on keeping it flat to the plate. So this is a good aspect ratio. It's not tall, so it doesn't want to tip. So, you know, it's a good demo piece. Oop, I just tore it. This thing's got some corners on it, so, and I'm not being like hyper careful here either, so, all right, let's take a look at that. All right, so it's starting to look pretty tasty there. You can't quite see yourself in the camera, but so I think we're gonna switch grits here. And so let me get it all squared away. I'll switch grits and we'll go to another grit. And then this is this is probably reflective enough that we can use an optical flat on it and look at fringes, okay? So this time I took a little more care putting it down, all right? So I think I'll be in better shape. So let's see, we were using 12 micron, and that's what we got with the 12. Let's go, you know what, I'm gonna jump down to 4, I think. Let's jump down to 4. It's a little bit of a big step. That's actually like a ton. I put a little too much on there. So let's try that. Spread that out a little bit. Nice big area there. You can see it's already darkening there because I'm doing something. And I got a little too much liquid on here. Take some off. All right, that's better. So it almost wants to like stick down when you got the right amount of lighter fluid. It doesn't feel like it you know, I mean, it's almost like vacuumed down. So now what's interesting is, you know, anybody can create this if you just have a flat surface. You don't have to now prepare a flat surface and then recondition it regularly, right? You can, I mean, look at that. That's working great. All right, so I think this will be good enough for us to do a quick check on it and see what we got, okay? So all this was real time. I didn't do any off camera or whatever. I did do the setup of the you know, the aluminum foil kind of off camera, but do some linear strokes here. And I'm just rotating. I'm not putting a lot of pressure on it here. Okay, all right. So what I'm going to do is I'm going to get the optical flat set up and the light, and then let's see. Actually, can you guys see yourself in the camera there? Oop, there it is. Is that it? There you are. Hello. Okay. Okay, so we're into the monolight here. Let me wipe off the optical flat here. And we'll set it on there. Let's see what we get. So let's see, let me move it so you guys can see it a little better. That's actually pretty good. Now, if you look at it, it's there's some edge roll off. Oop. There's some edge roll off that we would have to deal with. Okay, but that's pretty typical on something like this. So, but that's pretty damn flat across there. You know, that's a few millionths flatness from in this area to this area here. Those lines are fairly straight and fairly parallel. So that's on aluminum foil, folks, and that's a pretty powerful technique. So you saw what we can do with aluminum, just Reynolds wrap foil lapping. Now, one of the other things that Robin and I have been experimenting with is various kinds of aluminum foil tape. Okay, so that's 2-inch wide, 4-inch wide, and 6-inch wide. So expanding on that, you can do some additional interesting things. So now this is just regular hardware store 2-inch wide aluminum repair tape. And you guys may recall these little granite surface plates that I sell from time to time. This is an old one. This is what I started with. And these are nice for on the magnetic chuck. You can float an indicator around and actually measure things while the magnetic chuck is on. But we'll show that in a sec because I got a new batch of these. It almost rings down. But what we have here is we have a small version of this, right? So if you do this, let's just, do we have a pair of, yeah. I had to reach there and grab some scissors. Let me carefully discombobulate that. I'm just going to cut it longer because I can trim it off afterwards. So what we can do here is we can carefully peel this this soft aluminum foil tape here, like so, and then we can apply it to the little granite, like so. Okay, and I think you guys can see where I'm headed with this. Let me get my little roller here. Heck, I'll just leave it long. I don't care for this thing here. Well, now what I just created was let me just fold that over so I don't cut myself on it. And this has a nice little grip. So now I have a portable flat lap here. Okay, now I'm not going to charge it and do anything with it, but an example might be where you have to do some, let's say you were creating a big flat surface like this and you were doing some measuring and you said this particular area here needs a little bit of work, right? Well, you can charge this and then you can actually just work that area. Okay, instead of having a gigantic lap that you're covering this with, when you get down to the nitty gritty, you can actually lap these local areas very carefully here too. Okay, and that's all. It's basically pushing all the air out and then it's wringing down almost. So that's pretty damn flat, as they say. And you would charge it the same way, you know, just with a diamond, and then you can charge it right on the surface that you're using, right? So the key elements in lapping are the lap needs to be softer than the target material. So we could do this too, but it would be very difficult to do because of tipping. So if this is smaller than the surface that you're doing, then you can actually do something. But we would charge it in the same way. So there's another use. And actually, let me grab one real quick while I get you going. Now, this is a brand new one here, and I have these made by our friends down at Standridge Granite, and I sell these in batches. And I just sold a batch. If you guys are interested in one, shoot me an email, and I'll tell you how to put a deposit down on the next run of them. So I order them 50 at a time. This next order I ordered 100, so because there's plenty of interest in these things, and then I'll show you another use of how we use this over on the surface grinder. Okay, so this is kind of the primary use of these little mini plates. These were originally salesman's samples, and they're just cute as heck, but they actually have some uses. And so this magnetic chuck is on. But you can see here that we have now an indicator base that we can check features on the surface grinder with the chuck energized. So we go over to the surface plate and we can set a height from this surface to the indicator, and then we can bring that over here as a, oops, see I get grit under there. Bring that over as a, what did I do there? Is there a little speck of fly stuff on there? Okay, there it goes. There was a piece of abrasive or something under there. Anyway, then you can transfer that measurement to a feature that you're grinding on the surface grinder, okay? With the chuck on, so you don't have to disturb anything. So that's kind of a neat thing. And then you saw the hand lap setup. So like I said, if you want one of those, shoot me an email. Email address is at the beginning of the video. So shoot me an email and you can put a deposit on the next run. And then when they come in, I'll collect the rest of it and send you one. So.